Thank you. Thank you. First of all, just to explain, this paper should have been in tomorrow's session on papers from the journal, but I couldn't make it to there. So the organizers very kindly moved it to this session, but it's a little bit different to, to the other papers. So I want to talk about three very early examples of people thinking about the idea of machines that can reproduce and in some cases evolve. These are examples that are not very well known at all within the artificial life community. In fact, they didn't appear in the book that I wrote on the subject a few years ago with Alan Doran. But in the time since that was published in 2020, I've come across a few additional examples of early work in this area. And so I've written an afterword to the book, which was published in the 30th anniversary edition of the Artificial Life Journal recently. And so it's this paper on which this talk is based. So in this paper, I cover a few different examples of thought about self-reproducing machines that I've come across recently. Today, I just want to concentrate on the three main ones of those and give you a very quick introduction to them. So there's going to be work from a techno-utopian. There's going to be work from a scientist and engineer, and work from an author and poet. So three very different perspectives. So I'm going to start with a guy called Johannes Adolphus Etzler. He was active and working particularly in the 1820s to 1840s, and a very interesting guy. So he was German, born in 1791. And yeah, he spent quite a lot of his time traveling around the world. In particular, he lived in the US for a lot of the 1820s and 30s, and in the UK in the 1840s. He was an inventor and what you would call today a techno-utopian. He's not very well known at all today, but he was actually quite famous during his lifetime in the areas where he lived. He was best known for a book that he wrote in 1833 called The Paradise Within the Reach of All Men. And in this, he set out his vision, and it was a sort of political, social vision for a society where all human labor had been replaced by machines. So it was an egalitarian society where men and women could pursue whatever they wanted in their lives, and all their needs were provided for by machines. So he set out in practical terms how to achieve that kind of society. And so one of the lines of reasoning was that in order to replace human labor, it wouldn't be any good powering these machines by the traditional power sources of the day, such as coal or steam, because those sources themselves require human labor to produce and to transport. So he was interested in natural energy sources. So you could think of him as an early proponent of green energy, although his green credentials in other areas are questionable. But so he was thinking about machines powered by wind, solar, wave, and tidal energy, so that these could be as autonomous as possible from human labor. And in The Paradise and in a follow-up work called The New World, he elaborated both giving examples of the kinds of machines he had in mind, and also spoke about how you might go about setting up such a society from a sort of organizational point of view, and also how much it might all cost. And on the subject of costs, in amongst his discussion, he has this passage. So he says, and what is the expense for producing such great things? None, except for the first machineries of very simple construction, and for the first molds of all things to be artificially made. For the machineries themselves, as well as the molds for casting the materials for use, are to be made by the same machineries, and may be then multiplied to any number required without any labor or expense. So he had this idea of starting off with a relatively small number of machines, each of which was quite general purpose, that could do a wide variety of outputs. He was very interested in the idea of machines as being capable of multiplying their outputs and producing, easily producing multiple outputs and multiple copies of outputs. And so this idea of replication and reproduction was inherent in his thought. But here he's specifically thinking about a kind of collectively autocatalytic set of machines that between them can all produce the parts required to make new copies of all of those machines. So this wasn't by any means purely a pipe dream. This is very much a practical, social and political movement that he was setting in pace. So he also spent a lot of his career actually designing and in some cases building prototypes of the kinds of machines he had in mind. So at the top right here, there's a machine called the Satellite, was a general purpose machine for cultivating the land and harvesting. In the center there, there's a machine called the Naval Automaton, which is a self-steering machine that could be powered by both wind and wave power. He also thought a lot about regulation of power, because although these natural energy sources were great in terms of they didn't require human labor, they weren't very reliable or constant forms of energy. So he thought of water towers and other mechanisms by which you could take those forms of energy as input and produce a regulated constant output of energy. And he also set out plans for a whole city megastructure where a society of several thousand people could live with all their needs cared for by machines like this. So he's a very interesting guy. Unfortunately, things didn't end very well in this story. So by 1844, he was living in London and he set up a tropical emigration society. The aim of this was to attract people to join him in his vision. And over the next 3 years, several thousand people had actually paid money to subscribe to this society. And in 1846, over 200 of them set sail for Venezuela, where the government had granted them a tract of land to start building a community along these lines. Unfortunately, this ended in tragedy, and at least 23 of the group died, either in transit or through various accidents and illnesses. And yeah, frustratingly, very little is known about Etzler's life and whereabouts after this. There was a PhD written recently about his life and times, which gives a few clues. But yeah, he's a very interesting guy, and it would make a really good film. But yeah, not much more is known of him after that point. Anyway, so that's our techno-utopian. Moving very quickly now on to the second character, Frigyes Karinthy. Was a Hungarian author and satirist. And in 1916, he wrote a book called Voyage to Faramida. So on the left is an image of the front cover of the original edition in Hungarian. And on the right is a more recent English language edition. So in this story, the main character finds himself transported to a distant planet by a flying robot. I won't go into the details of how he got into that position. But when he arrives on this other planet, he finds that it's actually populated and home to a whole civilization of robots. And there's a factory there where the robots are building more copies of themselves. And again, much like with Etzler, it's a sort of autocatalytic affair. So there's a group of 7 or 8 robots, each producing different body parts, and then they're all joined together to produce the full robot. So I'm not going to go into the plot at all, but I just wanted to say a few words about the context of this story. So in Rise of the Self-Replicators, we talk about Samuel Butler and about George Eliot in the 1860s and 1870s, who were the first people who really explored at length in literature the idea of machines that could reproduce and evolve. But as the sci-fi genre develops going into the 20th century, Karinthy's work is, I think, as far as I'm aware, is the first example of 20th century literature that really explores this idea of machine self-reproduction. coming as it does 4 years before the publication of Karel Čapek's Rossum's Universal Robots. So yeah, in terms of early 20th century fiction, this is quite a important example, I think. Right, so moving quickly on. So we've had our techno-utopian, we've had our author and satirist. So the third person I want to talk about is a scientist and engineer by the name of Fred Stahl. Some of you may have heard of him. I suspect most of you haven't. So Stahl was a math major at Wayne State University in Detroit in 1960. And whilst he was there, he supplemented his income by working in the university's computer labs. In the years before this, his interest in the idea of self-reproducing machines had been piqued by reading a couple of articles in Scientific American. So he'd read an article by John Kemeny, which described John von Neumann's work on self-reproducing machines. And he'd also written the article by Lionel Penrose, which described Penrose's experiments with self-reproducing wooden blocks. So Stahl had the idea of maybe you could do that kind of system on a computer. And so he set about designing a computational system where he could write a piece of computer code that would make copies of itself and set it to work reproducing and evolving in a computational environment. So he actually built a system like this. So he wrote a language in which to describe these programs. It was based upon the native computer language of the system he was using, a Siemens computer. But it had some special commands to help with the process of reproduction and mutation. So it was kind of a virtual computer running this language on the base native computer. So he inoculated his system with a handwritten computer program, which did the following. It would move about in memory. And if it came across another instruction in front of it in memory, it would eat it. And once it had eaten enough enough instructions to make a copy of itself, then it would be moving forward and it would start producing an offspring behind it. And finally, that offspring would become a fully fledged functioning program itself. So he did all of this and in 1960, and he did some experiments. Unfortunately, the experiments weren't very successful. So what tended to happen was his handwritten program would indeed make a copy of itself, reproduce, but then the offspring program would catch up with the parent in memory and start eating the parent. So the parent would be killed and he would just have this offspring. But unfortunately, the offspring had lost the ability to reproduce by itself. So it was sterile. So you just had the offspring wandering around the environment for the rest of time by itself, which is a bit sad. But reading Stahl's account of this, there are so many things where you think, oh, if only he tried this or that, it might have been a lot better. He was so close, but unfortunately, his peers weren't very interested in this at the time. He showed it to a biology professor who kind of poo-pooed it. And so he went on to other things. But nevertheless, despite the lack of experimental results, I think it's quite significant in terms of the history of artificial life, because it's the first example of an artificial universe in which is based upon self-reproducing computer programs. So the year after Stahl did this, there's a better known example called Darwin, which was developed at Bell Labs. And then a bit later on still, there's Corewall, which is much better known. But both of those examples had self-reproducing code written in native machine language. And a consequence of that was that they were very fragile. You couldn't introduce random mutations to those systems because they were likely to crash the whole system if they were running natively. So Stahl's work on sort of solving that problem by having a programming language running on a virtual CPU was a way by which he could introduce mutations, whereas these other systems didn't have mutations. And if you want to look for the next example of comparable work of artificial universes with self-reproducing computer programs with mutation and evolution, you really have to wait until Steen Rasmussen's work on Core World, his Venus Core World, and Tom Ray's work on Tierra, which both appeared around 1990. So Stoll's work was about 30 years before this. So very significant in historical terms, I think. Okay, I'm just coming to the end, so just a few words to close up. So I've talked about ideas from science fiction scientists and engineers. You might ask, why am I so interested in science fiction? Well, it's often the case that in any field of study, ideas on the cutting edge are first explored by science fiction authors, whose very job is to look at the long-term implications and possibilities of a field. And so often you find new ideas coming up in sci-fi that are only later developed in science and engineering. So if you're interested in the cutting edge in a field, you could do worse than read a few sci-fi books. But that's not always the case. Sci-fi doesn't always precede science and engineering, and Etzler's work is a very good example of that. So he was very much had a practical project in mind and was designing real machines that might eventually be able to reproduce. And that came several decades before any literary work on the idea of self-reproducing and evolving machines. So this history represents a rich resource of ideas to tap if you're looking for ideas in a subject. So I've alluded to already this idea of collectively autocatalytic self-reproduction, which was apparent in some of these works. And that's very different to von Neumann's architecture, which was quite a monolithic architecture for a self-reproducing machine. There are other examples, self-designing machines, and a whole load of other examples that I discuss in the book in particular. But that's really why I'm interested in looking into the history, the deep history of these kinds of things, because they not only educate you on how long some of these ideas have been around for, but they're also a great source of inspiration for future work. And I hope they are to some of you too. Okay, thank you.